Our speaker today, Dr. Neil Daswani, has held a variety of responsibilities of research, development, teaching, and managerial roles at Google, Stanford University, Docomo, USA Labs, Yodlee, and Belcor. His areas of expertise include security, wireless data technology, and peer-to-peer systems. He has published extensively in these areas, frequently gives talks at industry and academic conferences, and has been granted several U.S. patents. He is the principal author of the book, Foundations of Security, What Every Programmer Needs to Know. Neil received his PhD and master's degrees in computer science from Stanford University and earned a bachelor's in computer science with honors with distinction from Columbia University. Dr. Neil Daswani.
Thank you very much for the introduction, Joel. So I'm going to be talking about what every programmer needs to know about security and where to learn it. One of the places to learn some of it is in a book that I recently published entitled Foundations of Security, What Every Programmer Needs to Know. I'll have a copy that I'll be raffling off at the end of class today. Over the course of the talk, I'm going to be mentioning various information resources. You can find those at my website, listed on this slide, as well as on a website that I'll mention at the end of the talk. Of course, if people have questions throughout the course of the talk, feel free to just raise your hand and I'll do my best to answer. So let me just start off with a little bit of motivation. Over the past few years, I've been monitoring press releases about vulnerabilities that have affected real users and real systems, and after looking at these press releases for the past couple of years, sometimes I wonder whether or not the sky is falling. To look at two representative examples of some rather spectacular data breaches that have occurred, I'll first mention the TJX vulnerability, which was announced earlier this year. So TJX is a company that owns TJ Maxx, Marshalls, and a number of other retail department stores. The bad guys were able to steal 45.7 million credit card numbers from them by driving up to the retail branches, parking their cars outside, and monitoring traffic that was transmitted over the Wi-Fi network. While they were using a protocol called WEP, the Wired Equivalent Privacy Protocol, to attempt to protect those communications, the problem is that this protocol has been known to be broken since 2001, 2002. It has a vulnerability in how the RC4 stream cipher is seeded, and because of this vulnerability, all the bad guys need to do is gather enough data packets to work backwards and figure out what was the initial state of the table, and basically they then get all the credit card numbers. Another spectacular data breach that happened about 2 years ago to the Card Systems company. Card Systems was a credit card payment processing company. When you submit your card to a point of sale station, that card number goes through a couple back-end gateways as part of the verification process. Card Systems was one of the companies that helped in that process, and basically they fell susceptible to an SQL injection attack in which they had a database of about 43 million unencrypted credit card numbers. What somebody at the company did was connected a website to it, which had various forms that allowed users to authenticate, choose accounts, email people, and whatnot. Of course, the attackers entered database commands into those web forms and were able to drop a script on the back-end database which would email them a couple thousand credit card numbers every day. And they were able to run the script for about 6 months until Card Systems even noticed. So they were able to get away with stealing 263,000 credit card numbers. Of course, there were 43 million that were exposed to the attack, so all 43 million customers needed to be notified. Visa and MasterCard canceled their contracts with the company. The company fell under FTC investigation, and needless to say, they're out of business. So while 2005 seems like a long time ago on internet timescales, one thing to keep in mind is that SQL injection attacks have still occurred quite frequently. In fact, if you go to a site like news.google.com, type in SQL injection, you'll just see article after article of recent vulnerabilities due to this type of attack. Data breaches like this have occurred a lot over the past couple years. There's a site called privacyrights.org which has been maintaining a pretty good chronology of all of these types of data breaches. Since 2005, there's been about 153 million compromised customer records of some kind, and in 2006 there were 300 incidents alone, which means one incident per business day. So there's a lot of work ahead of us in securing cyberspace, but basically from these issues, I hope you can see why I feel that the sky might be falling, and if it's not falling now, it might be falling sometime soon. So what I'm going to do in this talk is tell you about some high-impact threats and how to defend against them. I'll talk about SQL injection and cross-site-request-forgery. How many of you have heard of SQL injection? About half. And how many of you have heard of cross-site-request-forgery? Just fewer. So I'll talk about these particular threats, and then I'll talk about some vulnerability trends, and finally, to wrap it up, I'll tell you where you can learn more. So how did this attack at card systems happen? How does SQL injection work? Let me go ahead and provide a simple example of how this type of attack can happen within a two-tier web architecture, where one tier is the web server itself, and the second tier, of course, is the backend database. So you can imagine that a user might want to log into a web server or a web application rather with a username and password, and what the web server or the web server application might do is, given that username and password, it might want to check if the user is authentic. The way it does that is constructs a SQL statement, a database command, which says, tell me what the password is for the user name that was supplied. The SQL query might look something like this: select password from users where uname is equal to the username that the user supplied. So $username in this case is a variable that gets filled in with whatever the user inputs. Well, you could imagine that the way that an attacker might take advantage of this is, instead of entering a regular username, an attacker might enter a username like quote semicolon drop table users semicolon hyphen hyphen and enter something for the password. Really doesn't matter what. But if this is the username and this gets plugged into the database command, you could see how this good query now becomes a malicious query. The malicious query becomes select password from users where the username is, the quote closes off the username. So it's a blank username, semicolon. The first statement gets closed off with the semicolon, and the rest of the input makes up a second statement which drops the users table from the database, basically eliminates the record of all the users. So this is what's called a denial of service attack, where any user that tries to log in after this malicious input was provided will not be able to log in. Now, of course, the website could recover their password database from a backup, but that's pretty much inconvenient. By the way, the last two hyphens is absolutely required. What it does is it comments out the quote that the application provided. In any case, you could see that it's possible to provide the right tweaks to the SQL statement to make sure that it actually gets executed. Now, when you're looking at this kind of an attack, you might think, well, you might think, oh, well, what I could do is just filter out quotes, right? That should solve the problem. Or look for other characters like semicolons and make sure I just filter those out. And while that might be a good first attempt, it's completely possible to do an attack where even if your web server application is trying to filter out malicious input, it can still fall prey to an attack. So in this slide, I've provided a simple example of a website that might be selling pizzas for a living. It might have a page which allows the user to look up the order history of all of the pizzas that were ordered, and the user might choose the month. So in this case, January might get chosen, and you could see all the pizzas I ordered in January. The HTML for this kind of a form might look as follows. It might have a form on it that has a select block. The select block has a couple of options. There's an option basically for every month where the option has a name, month, and has a value, 1 to 12, depending upon which month the user wants to see the order history for. And there's a submit button at the bottom. Well, of course, an attacker can take advantage of this in an interesting way. You could imagine that the SQL query behind a form like that might be as follows. It might be select the pizza, the toppings,